In this video, we'll talk about writing an augmented matrix that will help us in our pursuit of solving linear equations using matrices. So the solution of a system of linear equations depends on the coefficients of the variables and the constant terms. If you recall just solving a system of two equations with two unknowns, we could use a method of addition. And really what happened, we used those coefficients to determine what we might need to multiply by one equation so that one of the variables would be eliminated when we added those. And so solving a system really of any dimension depends on the coefficients of the variables and the constant terms. So rather than using the algebraic methods that we've learned, we can use a different approach, which is to construct an array of numbers consisting of the coefficients and constant terms of each of the equations. This array is called a matrix. Well, a matrix is simply a rectangular array of numbers made up of rows, which run horizontally, and columns, which run vertically. The size of a matrix is determined by the number of rows and columns it contains. The matrix I have pictured here has 3 rows and 4 columns, so we say that this matrix is a 3 by 4 matrix. We always put the rows first times the columns. So when we use matrices to solve systems of linear equations, we create an augmented matrix, which consists of the coefficients of the variables and the constant terms. Each row in our matrix corresponds to an equation in the system. So the system that consists of x plus y plus z equals 4, 3x plus y minus z equals 10, and x minus y plus z equals negative 2 corresponds to the system or the matrix rather, that consists of the coefficients 1, 1, 1, and the constant term. So 1, 1, 1, 4 is our first row. The coefficients of the equation in the second row is 3, 1, negative 1, and the constant term is 10. The last equation is 1x minus 1y plus 1z equals negative 2. So in the matrix we write 1, negative 1, 1, and negative 2. Now let's try it. We want to write the augmented matrix for each system, or if we're given a matrix, write the system that corresponds to it. The tricky part is that each of the equations in the system need to be written in the same manner. The first system is 3x equals 2y plus 6, and x minus y equals 0. So we first need to rewrite the first equation in standard form, which is 3x minus 2y equals 6, and the second equation is x minus y equals 0. So we write an augmented matrix that consists of the coefficients and the constant term from each equation. So we have 3, negative 2, and we draw a vertical line to represent the constant term, 6. And then the coefficients of the second equation are 1, negative 1, and 0. So this augmented matrix is a 2 by 3 because it has 2 rows and 3 columns. Now we have a matrix, an augmented matrix given to us, which consists of 1, 2, negative 2, and 0, 1, 4. The equation or system that this corresponds to is, remember these are the coefficients, so x plus 2y is equal to negative 2, and 0x plus 1y, or y, is equal to 4. So in simpler form, this is x plus 2y equals negative 2, and then just y equals 4. The last example is a 3 by 4 matrix. It consists of 1, 0, 0, 9, 0, 1, 0, negative 2, 0, 0, 1, 1. To convert this to this system, this is x plus 0y plus 0z equals 9. 0x plus y plus 0z equals negative 2. And 0x plus 0y plus z equals 1. Notice that the coefficients of 0 can be omitted. So this is really the system x equals 9, y equals negative 2, and z equals 1.